Okay, so in this video, we want to review a basic property of fractions, which is the following. If the numerator and the denominator of a fraction shares a common factor, it can be cancelled. So think of ABC as positive integers, and look at the fraction AB over AC. Both numerator and denominator share as a common factor A, and this factor can be cancelled, and we will obtain a simplified fraction which will be the same as the original one, and of course the simplified fraction obtained is simply B over C. And let's look at why this is really intuitive if we once again think of a fraction as dividing up a circle into, in this case, C parts, and taking B parts out of the total number of C parts. And going backwards will show that this is really intuitive. So if you start with B over C, again, this is saying take a circle and consider this your whole, and now we divide the circle into C parts of equal size, and out of those C parts, we take B of them. Well, what's going to happen if instead of dividing the circle into C parts, we divide it into A times C parts? Well, if you divide the circle not by C parts, but by A times C parts, then you have A times more parts than you had originally, which means every part now is A times smaller than every original part. But you want the same ratio as you had before. You want to have the exact same amount, which means if every part is A times smaller and you want the same result in the end, you have to take A times more parts than you did originally. Therefore, you have to take A times B parts. And so you see, hopefully, that this property of canceling a common factor top and bottom of a fraction to yield a simpler fraction is very intuitive. Divide by AC yields parts that are A times smaller than the original parts, as you have A times more parts. And so to get the same amount, you take A times more parts than you did originally. Therefore, the ratio is preserved. Let's look at a few examples of this. So what if we look at different versions of 1/2 first? So if we take 1/2 geometrically, again we're saying divide the circle into two parts of equal size and take one of the two parts. So the shaded region corresponds to 1/2. What if we now take the circle and divide it into four parts? Well, it's pretty clear that if we want the exact same amount as we did before, we have to take two of the four parts. And then let's go backwards thinking of this property. If we factor the denominator, 4 as 2 times 2, then we have a common factor of 2 top and bottom, which can be cancelled. So on top we're left with 1, on the bottom we're left with 2. So therefore, 2/4 is the same as 1/2. What if we divide now the circle not into 4 parts, but into, say, 6 parts? Then it's pretty clear that if we want 1/2 as before, we have to take not 1, not 2, but 3 of the 6 parts. And thinking of this property and factoring of course 6 is 3 times 2, common factor of 3 top and bottom, which can be cancelled, leaves us once again with 1 over 2. Let's do one more example. Say dividing the circle into now 8 parts of equal size. So if we once again want 1/2 of the circle, we now have to take not 1, not 2, not 3, but 4 out of the 8 parts. And again, thinking of factoring, 8 as 4 times 2, and canceling now the common factor of 4, we're left with, once again, 1 over 2. Let's do one more example, but not taking 1/2, but taking, say, 3/4. So we start once again with a circle as a whole, divide the circle into not 3, but 4 parts of equal size, and we will take 3 out of those 4 parts. So let's shade what corresponds to 3/4. So this is now 3/4. And now let us divide the circle not into 4 parts of equal size, but say 8 parts of equal size. So if we want the 3/4 of the circle, we must take 2 pieces give us 1/4, 4 pieces give us 1/2, and so 6 pieces will give us 3/4 of the circle. But thinking again of factoring, 6 as 2 times 3, and 8 as 2 times 4, we have a common factor of 2 which can be cancelled, and we're left with 3/4 as expected. So the idea is, whenever you deal with fractions, you try and deal with fractions that are as small as possible, thinking of the smallest possible numerator and smallest possible denominator. So you should always look, when you have a fraction, for possibly a common factor on top and bottom, and if there is such a factor, it should be cancelled to yield a simpler fraction. And that's it.